Welcome to day 3 and session number 2. Dr. Jitender sir again will continue with his lecture. This session will be chaired by Dr. Pooja Gupta. She is a co-host now. For any queries, you can directly message to everyone in the chat box, or you can post your queries to Dr. Pooja Gupta. And for attendance related issues, there is Miss Mahima Malik. She is also co-host right now in this workshop. So you can post the queries related to attendance. Yes, Dr. Jitender, please continue with your lecture, sir.
Yeah, thank you, Dr. Suraj. Welcome, participants. So
Good
I hope,
afternoon, sir.
yeah, good afternoon, madam.
I, Dr. Pooja Gupta, welcome you again in our 2 weeks workshop on MATLAB and Python. I heard your previous lecture, sir. It was quite wonderful, and we and our participants learned many new commands of MATLAB. And to learn more commands of MATLAB, I request you please continue with your fourth lecture, sir. Thank you, sir.
Thank you, Dr. Puja. So thank you for your kind words and welcome, participants. I hope you must have learned some commands in basic MATLAB programming, and we have till now we have learned the three major components of MATLAB programming. The first one is the command window. Second one is the working with script files, and the third one is working with function files. Right. So we know now how to define functions in at least in one way. As I still remember, so I repeat it once more that when you want to obtain make a function file like the way we have introduced to you, that function file needs to be so the name of the function file is important. So name of the function file should be the same as the name of the function which you have given in the very first line of the function file. So script file and function file, they are saved with the same extension name .m, but function file is different because of the first line of the function file that is different. That is the first word is function, and after that the output variable and then the function name. So output variable and then the function name and then the number of variables which you can put in. Sometimes your output depends upon parameters, so you can insert a parameter as a variable in the function, right? So this way you can proceed. So you can define any function of your choice you want, and within a function, if you want to define another function, you can proceed this way. In fact, not only this, you can define function of a function. You can define function of a function as well. So for that part, now we are going to proceed. So in this lecture, I will try to solve some mathematical problems for you via MATLAB programming. And by this, I hope that you people are familiar now with the for loop at least and if statement, right? If statement and for loop. These two things were sufficient. Otherwise, there is no limit to MATLAB programming or any programming language. So more you do it, more you learn it, and there are, plenty of commands, more commands in MATLAB. But we will stick to those commands which we can immediately utilize for beginners to understand these things, and not only for beginners, those who are pursuing research in numerical analysis or some sort of things where they can utilize numerical evaluations, or those who are interested. Maybe sometimes what happens, interdisciplinary science students, they want to have bar graphs. They want to have they use usually Excel or something else to other packages to obtain such graphs, two-dimensional graphs. But in MATLAB you can see so there are, because of this, latex compatibility with the latex symbols, and the ease of utility makes MATLAB much more beautiful than the other things. So I strongly recommend to those who are working in interdisciplinary areas to use MATLAB, and this is a very good software package. And if they cannot afford MATLAB, they can utilize this one, Scilab. So trust me, this commands in Scilab and MATLAB are almost same. The only thing is that the order of arguments may differ, but otherwise commands are almost same. Working procedure is same, so no difference in that. So Scilab I mean, immediately after learning MATLAB, you can start with Scilab. So you do not need to learn Scilab separately. Scilab will be, you will automatically understand Scilab, right? So once you know MATLAB. Okay, so now in this, as I promised, so I would like to introduce to you more sort of functions. Um, I have prepared this file for you. So earlier, I just demonstrated regarding the how to plot. So some nice commands regarding plotting functions, right? So now I will proceed with this one, the next one. So where it is. So let me comment it first. So you have now. So next function I am defining here. So this is a script file first of all, and I am going to define a function for you, and I need to plot this function. So another thing is, what if you do not want to, if you want to utilize a function for its instant use? Okay, so if you want to use a function and you want to define a function within script file, script file is different. So this file, run this file. I have prepared this script file for you. So the way is, such functions are called as anonymous functions. We call such functions as anonymous functions. Okay, so for figure 2, if you want to plot, so you can just, this is a command for you. So if you want to plot uh, 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 this function in the second figure, so just make a command figure number 2 here. Okay, so figure number 2, we will plot this function. Okay, so maybe function or its area. So function is f1 again, f1 or a func1, two functions we have defined already. So we are picking up, and using this function, I'm defining a function g. So without using this function, you can define g. You can just, I mean, you can just after. So how you define an anonymous function? You just use at the rate. Okay, at the rate. This function you will use. At the rate function is a function for the argument. Function of the argument. Function of which variable? Okay, g is a function of at the rate of x. That is, g is a function of variable x. And after this, the expression for g. So I have written the expression for g to be the expression for f1. You can utilize it. You can write it this way also. Just hold on, this way also. Maybe x square, right? Minus 2 star cos of 3x minus 1, right? Something like this. So just after declaring that the function at the rate of x, so this would mean g is a function of the variable x, and the expression for g is this one. Immediate expression for g is this one. So those functions which are very simple functions. So for simple functions, you can just use anonymous commands. So for anonymous functions, you can declare them as anonymous functions, and you can insert somewhere a also. So maybe a is here, a star x square. So you can just use this now, and you can just, I'm interested in plotting now area of this function. Okay, so area of this function with respect to the parameter a. So how the area under the curve defined by this function varies as a varies from -1 to 2, right? So the area is, so you can use the command for area to be quad. So this is the Gaussian quadrature. Alternatively, you can use the Simpson's rule or some other integrator. But right now we are using built-in MATLAB function, quad function, okay, for one variable. So here the function name, and then after the starting point of integration and the interval of integration, like this, you second argument will be the final point of the interval, right? And then counter, I have defined c to be equal to 1, and within the for loop, a from -1 to 2, and step size is 0.1 here, right? And then update c to c+1, and the output variables will be stored here. Value of a will be stored in x, and value of the integral of g will be stored in y, right? And then after ending this loop, you can plot it. So plot x comma y, and the color specification is red color, and line width of the curve is 2. So let us run this program and let's see what happens. So you can see, I hope you are able to see this this here. Okay, so you can see this figure, figure 2 opens up, and this almost straight line is appearing. It depends upon the function actually. So if you insert here maybe a square here and something like 2 star x star, so dot star I will have to put here because I'm working with an array here. So array command will be required. So you can just run it again. Let's see. Yeah, so now it has changed. So some sort of this graph will appear. Okay, so the same thing. So if you would have worked with F1 also. So alternatively, if you work with F1, you can just obtain the similar output once more. So if you just want to work with F1, so I'm commenting the other part. So you can just do it this with F1 also. So something like this. And if you use, since I have interchanged the this one, so this is why it is different. Otherwise, you could have got something else, right? So yeah, well, so here we are. Sorry, we are obtaining here integral graph of the integral actually, right? So this is something different here, right? Graph of the integral of g. G as well as integral of g is depending upon a, right? So that way, so we are doing something else here, right? So this is what I wanted to do with the via this script function, script file. So by this we have learned that script file. So script file, within script file we have opportunity to define functions like this. The syntax is @ within braces mention the variables. If you want to make function as a function of 2 variables, you can just insert x comma a here, right? Otherwise you can just consider x as a number of n variables sitting in x itself, right? So that way you can utilize this one. So, okay, so next one is then we have another command to plot a function. I have this one. So I would have done it this way also. So in the very first figure, we plotted a function, right? So the same function, same thing can be done just by declaring a as a column vector, sorry, as a row vector, 4 points, -1, 0, 1, 2, and then you can just define g again as an anonymous function of x via f1 xa, and you can straightforward, you can fplot this function. So you can use the command fplot to plot this in this function g, and the limits for x are from 0 to 5. So it will automatically take care of the mesh, right? So mesh size. So you can just see let's see the output here. This is in figure 3. Let's see. So yeah, so once more the similar graph which you were expecting for the figure 1 earlier function f1. So for the various values of a. So so this is without using the for loop, right? There I used for loop for a, right? So the very first program, if you remember, I used the yeah, for loop there, right? I use the for loop there, but this is using the anonymous function without using the for loop, right? So we can do it this way also. So okay, so and then if you want to then is the coordinate 2-dimensional things. If you have, if you define g1 to be another anonymous function of 2 variables this time, variable a and x. So treat a as well as x to be two variables now. And if you want to integrate this function g1 with respect to a as well as x, okay, so on some rectangle 0 to 1, so -1 to 1, so you can just do it this way. So there are other options you can explore on the documentation part, that it can evaluate on the double integral on non-rectangular domains as well. Okay, so which are dependent upon x and y. So on those domains also it can work. So you can explore more on this. I recommend the search option in documentation part. You go through this and you will be able to see that. Okay, so you can just, for the last one, you can just see what is y. So you can just see here integral is, so 2-dimensional integral of f1 ax when a varies from 0 to 1 and x varies from -1 to 1 is this one. Okay, so this is how 2-dimensional so, and this is ready-made. The only problem is you do not know about about the quad 2D and the quad this one just quad. Okay, these are built-in functions. So sometimes what happens, those who work in mathematics, they do not trust. I mean, sometimes they may not trust this because they are interested in mirror analysis of the method. Okay, so they would like to program their own quadrature rule, right? So if you want to implement now Simpson's rules, for example, then let me make a program for Simpson rule. So how to generate a program for Simpson rule? So step by step, I will let you know. I am just going to define a code. I'm going to write a code for Simpson rule, right? So for Simpson rule, I can just output is y and input is, say, maybe I can call it as Simpson, right? Simpson or the Simpson's rule 3, right? One third rule. Okay, so for this, what do I need? I need what you need to recall the Simpson rule first of all. Then only it will make sense, right? So let me save it first on the desktop. So, Simpson rule. So I need a function to integrate first of all. So maybe f. Then I need a function to integrate from some initial limit to final limit, maybe a to b, and then the number of points of integration, say capital N, right? This much I need, perhaps, right? So function, I need a function f to integrate using Simpson rule. Initial point is a and final point is b, and then other things you can fix using capital N and a and b, right? So let us try to. So finally, final answer should be y here, just to not to, right? So final answer would be y. So now what I will do, step by step, I will program it. So you need to recall the Simpson's rule first of all. You should know the Simpson rule mathematically first of all. If you remember, you need to divide the interval in, you take n to be even, right? First of all, the number of subintervals should be even, and so that the total number of points should be points of evaluation should be odd. So these things should be in hand. So, and the integral formula is, first of all, let us write down the formula and then we will reproduce the steps accordingly. So we need to know y is actually equal to, I think h star, h by 6, I think outside. And what is h? H we need to define. H is equal to the this step size b minus a by. So I will use, rather than using n, I will use even number. So 2 star n. So I will use 2 star n. Okay, so 2 n number of points I need. H star by h by 6 star, and then it should be now. I need 3 kind of sums here. So I will call them maybe sum 1 plus sum 2 plus sum 3. So 3 kind of sums I need to evaluate for this one, obtaining the Simpson's rule. The first sum should be the sum of the first and last term, right? So first term, so sum 1 should be equal to function f of function value at the first point, that is a, right? So that is a, and and plus, maybe you can define first of all what is your x. X should be equal to, starting from a to step size is h and then to b. This is your x. Okay, row vector x here, right? And then this should be now f of a plus f of so, and you can define here yeah, so f of a plus f of b. I think this is the sum of two first and last term, right? And after that what you need to do is, if I can recall, I think even terms are multiplied by 2 and odd are multiplied by 4. Dr. Pooja, can you help me? So regarding Simpson, can you recall the Simpson's rule? So is it 4 times? So I think 2 times even terms and 4 times odd terms, I think. So we have to program accordingly. So I think I can update this one.
Hello.
Yes,
Hello.
yes, Dr. Pooja.
I think half we take common, then we take fa function की value of function at a and plus function of b, then 4 times the value which we take. So I think it is right, sir.
4 times odd and 2 times even.
Sir, FA plus FB,
Yeah,
and then yes sir, yes sir, yes sir.
2 times even and 4 times odd. So
Sir,
let's see if it now. So
actually
it
by
was like,
form, sir, actually by formula I solve it, sir. Actually, we take in Simpson's method. We take a linear approximation of a function, and then we find the integration of the linear approximation. So by formula, I solve that, sir.
so okay. So just let me check. Maybe I have prepared somewhere this file, so I can just copy that. Simpson is there, I think. So let me check it. So I have already made a program, but I just want to. Yeah, this is there. So this is 2 times odd and 4 times. So 2 times even and 3 times odd. 4 times odd. Yeah, this is correct. So this is correct now. So for j from 1 to 2, so just hold on. Just let me just explain from here itself. So j is from where to where? So I can just in the first strike I can evaluate f of x. Na? X is in front of you, x is a to b, na? And f step size h. So you can evaluate straightforward x. So let us take y to be equal to f of x. So this evaluates f of x now. And now, so what we can do is, so sum one would be y of y at 1 and y at 2n plus 1, isn't it? Or the end. So so y is a row vector, no? So y last term in the row vector would be this term, and the first term would be this one. So what is the size of y? Size of y would be 2n plus 1. So 1y. So first row vector of size 2n plus 1, because x is of same size, no? So you evaluate f of x, and then after sum 2 I'm taking 0 and sum 3 I'm taking 0, and I'm now taking j from 1 to or first term I have taken 2 to 2n, only 2n star n, right? So we will just step by step for loop, and let me end this loop first of all. If now I use the if command, so step by step we will learn it. So if j is, if remainder of j when divided by 2 is equal to 0, so double equal we will use, okay? It's conditional statement. If this is equal to 0, then we will define sum 2 to be equal to sum 2 to be equal to sum 2 plus 2 times 2 star y at j, is it? Y at j, right now. So y at j, else we will do. So now we'll use another command, else. So we have conditional statement. If this is then, and then we will use the else command. Else we will use sum 3 equal to sum 3 older 1 plus 4 times 4 star y at j. Let's see it works or not. Okay, so if so, either it is, so either j is even or it is odd, right? So if it is odd, then we will multiply it by 4, or and we will add up all these three. So, and the Simpson rule tells us that it is hy6 or hy3. Let me verify this. This is I've forgotten. This is, finally the formula is hy3. Yes, it's not hy6, hy3 it is, right? hy3 star sum 1 plus sum 2 plus sum 3, right? So this is now and for loop has to be ended. So if statement I have ended, so for loop also ends here. So function also I have used, right? I hope that everything is now clear to us. So what we are trying to do, sum 2 will store the sum of all those numbers which have been multiplied by 2, right, in the list of function values. All right, and then and sum 3 will store all sum of all those numbers which have been multiplied by 4, right, in the functions list of function values at the corresponding values of x. X is from a to b, step size is h. I think this is now fine. And okay, so otherwise, if you want to use else if command, you can use else if also. Else if remainder of j with respect to 2 is equal to is equal to 1, then it is the odd term. So for this, we will multiply by 4, right? So let's see whether it works or not. Okay, so this is the, so we have designed our SIMP3, right? And when we will call SIMP3, we will have to memorize this syntax. Okay, so SIMP3. So let's see whether it evaluates correctly or not. And let us choose our function, a nice function. So func1, I will choose function of one variable only, say maybe x, and just remove a from here right now and make it simple, so that just to verify that our program is correct. So integral of f this just 1 plus x, its integral from 0 to 1 should be so maybe just make it only x, right? X squared by 2. So half integral should come out to be half for func1 right now. So let us now try out the integral. So we will type simp3. Our function is now at the rate of, we will call this function now at the rate of, function is func1, right? And then func1, and then accordingly just hold on. Func1 is a function of one variable here, right? And simp command is, this one, right? Simp3 f I have mentioned. Initial point is a is a 0, final point is a b, that is 1, and number of points that depends upon us. So maybe if I want 10 points, then let's see what's the answer. So it's approximately 0.48. So I think our formula is correct. So let's move to 100 points, say. So it's almost correct now. So you can see now that our formula is working. Okay, so now number of points, now it's up to you, because integrals, there are some weird integrals. If you have, say, sine of, say, 10x, then, and if you want to still integrate it, so such functions which are more oscillating, so their integrals are difficult to obtain numerically with fewer number of points. So you have alternatives. So but the way is, so this is the simplest way to demonstrate MATLAB programming for the Simpson rule. So I think that all of you should note down this function first of all, just for your reference. I will give you just 2 minutes to note down this syntax. So simp3 is the name of the function file, and so I will be back after 3 minutes. Okay.
Hello.
Yes, Dr. Bhuji.
Sir, there are two questions from our participants.
Yes.
So first is, can we check a set is a group or not by using MATLAB?
That requires MATLAB programming. So you have to make an appropriate program. So the problem is you have to consider the binary operation first of all, and you have to take all the possibilities. You make a matrix, right, and check out the matrix elements. Yes, of course you can do this, but with some effort.
Yes.
Only for finite groups. Okay.
Only for finite.
Yeah, only for finite groups you can check it.
Sir, second question is, can we check the continuity of a function by using its graph through MATLAB? By making its graph in MATLAB?
Yes, of course. You can just look at the graph, you just draw the graph, but the thing is, mesh should be sufficiently large. Okay, so the number of points taken to draw the graph should be as large as possible. For example, sin x over x. Sin x over x, this function is not defined at x equal to 0, right? And sin x over x, you just take sin x over x to be equal to at 0, you take sin x over x equal to 1. Then you can just draw the function. So let me just define it on this function. So first, let them note down all this. So I will let you know about how to check continuity, limit, and all these things. See, you can check them, but that is not the proof. Remember this thing.
Yes, sir, but actually, as you're talking, so for that we already know that this function is discontinuous at a point, and then point is 0. But maybe it is possible that sometimes we don't know where the function is discontinuous. So in that case, how we will check the discontinuity of a function?
Yeah, the problem is discontinuity you can check using graph, but continuity, to check the continuity, it will be hard, because sometimes because there are limitations of the computer algebra here, because
Yes.
it works on finite arithmetic. So the problem is that sometimes you may see that the continuous curve you may be able to see, but the actually the function is discontinuous. So sometimes you may be able to see some discontinuity, but ultimately the function is coming out to be discontinuous, because there may be an interval of I mean very small size where the function is taking large I mean different values, right? So these things are weird sometimes, but yes, most of the times if the functions are well behaved, you can just guess it correctly from the graph itself. Only in some cases, I mean most of the cases, but don't we cannot you cannot say that that is the proof that the function is continuous. So I have examples of functions which you cannot guess while looking at the graph the function is going to be continuous or not. So that is a bit ultimately you cannot get rid of mathematics, right? So MATLAB is just to help you to do mathematics. It doesn't mean that it's a replacement for mathematics.
Okay,
So
sir.
yeah.
Next question is, can we write the code of function in editor file?
Can we write the code in editor file? Yes. Yeah. This is see, it depends upon what kind of code you are interested in. So if you want to define a function like the Simpson rule I have defined, then you have to define it as a separate file. And then usually the script file, the editor file within the editor, the script file is for compiling the various functions. Okay. So two kind of codes are there. One is the single code for function file. That is the different file, right? Other one is the script file, where what you will do, you will compile the as many functions file as you wish for your program. Okay. So coding is two-way here. Okay. So one code is written in script file just to compile everything appropriate for your program to run up. And then there are several function files, okay, different function files which you are compiling in the single script file, right? So yes, so you can do
Okay.
this.
So next question is, what is function 1 in command window? What is function 1 in command window? Do we separately need to write function file after writing sim3 function as a script file?
Can you please repeat the question?
Sorry, sir. What is
Please.
function?
Yeah.
Yes. What is a function 1 in command window?
Func
Do we
one. Func
sep-
one we have all once we have
Yes, sir.
defined func one, so
Yes,
it
sir.
becomes universal now. It becomes universal for your folder. Okay. So when user defines the function func one, the problem arises when the function which you are defining on your own, its syntax, its name matches with the already built-in function in MATLAB. That will produce error. Okay. So you have to be careful that so if function is not producing any error, so such kind of errors, so name class should not be there. So don't use any built-in function name to name your own function. So user defined function, once you have defined it, it becomes universal now. Okay, so you can utilize anywhere now. This func one, you can I have used this func one in my run this file also, right, and session2 file also. So anywhere you want to use it, you can use it. Yes.
So, sir,
Yes.
do we separately need to write function file after writing sim3 function as a script file?
Yes. So sim3 is now, once we have defined sim3, now sim3 is a function of function f.
Okay.
Sim3 is a function of function f now. In other words, it will work like like you use we use the built-in command quad for obtaining the quadrature of function. So quad command does not depend upon whether function f whichever function f you take, it will obtain the area of it will give you the area of the function f. Similarly, sim3, whichever function you define for that function f, it will evaluate the area of the function using the Simpson rule, right? Which we have for which we have written the code, right? So this is the nice thing about. So sim3 you have to only make only one file, right? And for function files, you change the function accordingly, you will get the area, right? We will not have to change the sim3 now. Okay, so you need to you have to you can close this file afterwards once you obtain a function file. So this is the way you obtain a universal file. Similarly, you can obtain another file, function file, for implementing Runge-Kutta method or of solving ordinary differential equations, right? Or system of ordinary differential equations. So for that part also, Runge-Kutta you have to design only once, and then you can it is for the it is for use to solve as many number of differential equations as you want. Right. Next,
Okay.
please.
Thank you, sir. Till now, these are the only questions.
Okay, thank you, Dr. Pooja. So I hope that you have noted down the same three. So I'm now closing it. So you can now utilize it anywhere you want. Okay, same three. And function also, you can just complicate the function. Let's see this function, this complicated function, right? Gx. So maybe something like this. So func1, I have changed the definition of func1 now. Let's see now. Same area. So let's see. So func1, I'm using the same function and sim3 on this. So let's see what happens to the area. So the area is now different because it will depend upon the type of the function we're considering. So this is the area using Simpson rule. How many points? 100 points. Now after this comes the error analysis. So error analysis, once you know mathematically what is the error analysis behind the Simpson's 1/3 rule, right? How many decimal places you need to have your answer correct. Then that requires some mathematical part, and that mathematical part as it is you can implement here. Okay. So I will not go into the detail of that because most of you are, I mean, even if you are working in interdisciplinary kind of mathematics, you are aware of error analysis, so you can just implement accordingly. The main thing is that how to make a program up to your convenience. So Simpson rule was coming to my mind. Another question which is coming to my mind is this one. Suppose you have a standard question in programming. You have a bank loan, and suppose you want to calculate the monthly installment. Okay, for n number of years you have taken it and you want to calculate the monthly installment at some rate. Okay, so what is the monthly installment for if you want to calculate it using MATLAB? Okay, so how to make a program for that? So let me proceed for that. Perhaps I have some old program on this, and let me check out if it is there. Then I can just copy and paste it for your, just to save the time. This is somewhere, I think. Yeah, so I have somewhere. Let's see. I would like to share with you a few things because some mathematics is needed to. So I have a file. So I would like to share that PDF file with you first, and then after we can proceed. Right. So just hold on. I can now share something else. Yeah, you share. I want to share this file with all of you. So I don't know. Is it visible now? Dr. Pooja, is it visible? What is visible in the screen? Hello.
Hello.
I mean, is it visible on the screen?
Yes,
The
yes,
PDF
sir.
file?
Yes, sir. Yes, sir. It is visible.
Yeah. So I make you people understand this simple problem, and we will later on we will program it. Okay. So look at this. So suppose you want to calculate EMI. You have taken a loan, say amount A0 units at a rate R% per annum for n years, right? And suppose you want to calculate the monthly installment, right? So monthly installment, that is EMI for this loan. Suppose it is X. Then step by step you can calculate the interest. Okay, so our aim is to calculate X. What should be this X? Okay, so monthly payment, what should be the monthly EMI for this loan to cover within n years, right? So if I1 is the interest on the loan amount during the first month from the date of receipt of the loan by you, then you can calculate I1 will be equal to P into R into T. This is the and T I'm taking this to be 1 month is just 1/12 year, right? So this is the interest uh, during the first month of after you having your loan, right? And then the amount of the loan after 1 month from the date of having the loan would be, say, amount will be A1, and it will be A0 original plus the interest minus the installment, because you will pay X amount in the first month, right? So then you will get the A1 to be equal to, so A0 alpha minus X, where alpha is just this thing in the braces. Okay, now what happens? So similarly, now new amount is A1 after 1 month. So after 2 months, what will happen? You will get A2. The amount after 2 months will be, so you will give an installment of X that has to be subtracted from the previous one, plus plus the interest on the amount, right? So this thing out in the preceding month. So you will get a2 to be equal to a1 alpha minus x. So a1 alpha we have already calculated, that is a0 alpha minus x. So you put it here, you will get something like this. You keep on going like this inductively. What you get ak after k installments, right? So you get ak to be equal to a0 alpha to the power k minus x times this geometric progression. Okay, so you can add up this geometric progression, and in fact you can find out the x in closed form actually. So in closed form you will get, you solve it for, after k installments, what should happen after k installments? Your amount should be 0. Okay, so the condition is after k installments your amount should be 0, and k would be 12 times n. So after, if n years, for n years you have taken your loan, then for 12 months, after 12 months the amount pending should be 0. So this is initial condition. So put it there and put it here and put it equal to 0. So after put k equal to 12n and put this equal to 0, what do you obtain? You obtain x to be equal to something like this, and this is the monthly installment which you need to pay. But numerically it's easy to calculate, but by hand it will be a little bit difficult because so many things are involved, right? So let us implement this thing in MATLAB. In MATLAB, we do not need the formula, but we will solve MATLAB just by using certain built-in commands. Okay, so let me share the MATLAB part now. So come back to this was just to understand the problem, and now come back to this one. Okay, so we want to make a function, right? To define a function which should evaluate this monthly installment, right? So for this we have, so let me define another function. So function file. So you have several ways of doing this, but I just want to let you know about how we can do this using a function file. So function file, I'm naming this function as EMI. So maybe EMI out to be equal to EMI. So in, so just EMI LOAN, say 1 as a function of how many variables. So we want this to be a function of how many variables. So we need several things together, right? So we need maybe so we say x, comma a, comma interest is r, comma y. So 4 variables I'm taking here, and after this what we can do is we have this one. We have to define n to be equal to, so y number of years. So n is the number of installments. So n is equal to 12 star y. So you can just comment here, write a comment here. Y is the number of years, right? And then r is the rate of interest, right? Interest, right? And so on, right? So I will explain one by one these things to you. So 4 variables I'm taking, and x is the monthly installment. Okay, so x we need to calculate. So function of x it would be actually, right? And then what is a? A will be the amount, right? So a is the, so I can write in comments, right? We can write in y is the number of years, right? And then r is the rate of interest, and a is the amount of loan, right? So these 3 things. So let me save it on desktop as a, so the function file is now me loan 1, right? And is a function of 4 variables, right? And then insert the for loop. Or so I demonstrated to you in the PDF file right now. So we need to have at every step what we are trying to do. We are calculating interest at every step, at every installment. Okay, so that formula we need to write here, right? So what is there for I from 1 to how much n, right? So up to nth installment, what should happen? Amount, the new amount is equal to older amount plus interest. So I can write interest 1, right? Interest previous amount plus interest minus minus the installment, right? Minus installment is x, right? But x is not known right now. X is just a thing which we need to calculate. And interest one, I'm defining this to be equal to P into R into T over 100, right? So what is that? A amount star amount into P into R, rate R into time, right? Time. What is time? Time is the number of months, right? So that will be now. So it will be now into 1 by. So only 1 month we are calculating every time. So 1 by 12, right? It will be now 1 by 12 over 100. So 1 by 12, 1200, right? 1 by 1200. So this is now the interest calculated, right? So after calculating this interest, what we will do, we have to end the loop, right? We have to end this loop. So what is happening? So after n number of installments, what we will get? We will get the amount after that, and we want this amount to be 0. So in other words, what we are supposed to do, f is a function of, so a is fixed, amount is fixed now, is a parameter, r is rate is fixed, and y is the number of months, number of years, it's also fixed. The only thing is x, and x is our installment. So let us write it here, and x is the EMI, right? Monthly installment, monthly, right? So now to obtain x, so what is ME loan 1? So it will be now ME loan 1. I'm defining this to be as A. So final amount after n number of years. So final amount after n number of years, what do you want? This should be 0. So that means you want to solve the equation ME ln 1 as a function of x equal to 0. So you need to find out the solution of this equation, right? So function is already we have defined the function, right? So let us proceed for solving this thing. Okay. So now for solving this, you need a script file, right? Or you can directly solve it. So there's no problem in that. So you have this command. You have the F0 command. F0. So Newton-Raphson method, right? So you need to solve by Newton-Raphson method or bisection method or something like that. So you can proceed with this kind of things here. So F0 of what you should write here. F0 of the corresponding function. Okay, so this is the command here. So we have to copy and paste few things here. Okay, so let's see now. I'm just copying and pasting this command from the function which we have defined already. So function should be F0 at the rate of x, and this is ME ln 1 x a r time 1, right? So this is what we need to do now. So what is a? But a we have to mention. So what is a? Amount is, suppose we have say 10 lakh amount. Okay, 10 lakh amount. So is it so, and rate is suppose rate is 16%, right? So and time is, suppose how many years you want, maybe 5 years or so, right? Then let's see what will be the EMI. So you have to initialize it. So you initialize it using maybe 2. So this is the initial guess. Okay, so because Newton-Raphson method is being, so how you call the function F0 at the rate of a function of x, this function, but with respect to x we need to find out its 0, and then after the other arguments are written as it is, and then the initial guess. So this is the next argument would be the initial guess, right? So let's see whether it's equal or not. So it's not picking up because the function we have been defined. Spelling is EMILO. So this is fine. So just hold on. Let me check it once more. Let me do it first in this one script file. Then we will have it. Okay. So let me define it this way. Oh, EMI out. So I haven't defined. So yeah, problem is with the definition of the function. Output variable I have to define. So I hope you have understood this mistake now. EMI out. The function, the command was correct, but the function was, so output variable you have to define. This is our A. Now the definition of function is complete. Now come to this one. Now come to the earlier command. I wrote this one, right? So look at this. So this is, now you can format long it. You can just, it's about the money. So if you would look towards the, you can just see the answer. So this is the installment into 10 raised to power for 24,318, right? So this is how, so you combine up your mathematical logic with the programming. So this is how you will be able to. So next time, if you want to calculate, if you have a bank loan, so using MATLAB is just straightforward. Of course, this is otherwise also easy, but if you are well equipped with MATLAB, you can just, you have already programmed with you, so no need to worry about this, isn't it? Just for fun, okay? Yeah. So Dr. Pooja, is there any other question, please?
No, sir. Till now, there is no question.
So
The question
this was,
already I asked.
yeah, this was regarding the MATLAB program for obtaining the EMI for the bank loan. Okay, so I will close it now. And yeah, so coming back to the other type of things in with MATLAB. Now I'm coming to matrix, little bit of linear algebra, right? So next is how to calculate eigenvalues and eigenvectors. You are most of the times you are interested in doing that because eigenvalues play a central role in linear algebra. So we have built-in commands in MATLAB, and of course you have certain kind of decompositions, Gauss-Jordan, Gauss elimination, so many things you have with you. So those things can be implemented as it is. So I think I should give these things as exercises for you. So exercises. So try to implement Gauss elimination and other related methods for solving. So just hold on for implement these things, Gauss elimination, other related methods for implementing for solving linear systems of linear equations, right? For solving systems of linear equations. So these things you can try to implement yourself. By default, A/B that tells us, so that involves Gauss elimination method, built-in function, MATLAB function. But many times you may not use, I do not recommend the use of built-in functions unless you know about the underlying program. Okay, so to be on the safe side, regarding the mathematical people, they should take care of the working procedure of the underlying program first. Okay, so don't use any built-in function blindly. So just take care of the mathematical part first, and then you can proceed. So, but here, if you want to obtain eigenvalues and eigenvectors, LU decomposition and everything like that, so there are some standard packages within MATLAB. But you can try to program your own packages, right? So your own commands, your own function files, so that you can better understand the linear algebra using MATLAB. So right now, I will just let you know about some built-in commands. So if suppose you have a square matrix, suppose so maybe I can work in some script file. So let's work with this file. So suppose I have a matrix. So just I need this window now. So I have, so first I can use this command clear all, so that it will clear all variables. And then if you define a matrix A to be equal to, say, 3 by 3 matrix, say 1, 2, 3, then you can define its second row would be, say, 0, 0, 2, minus 2, right? And then third row is, say, 0, 0, 1.2, right? So 3 by 3 matrix I'm defining. And if you want to see its eigenvalues, just look at this. Just use the command EIG of A. There are several other options also. You can just see the output here. Let's look at this. Let me run it. So there is a mistake here. Clear all. It should be clear all. So look at this. You are able to see few things. So what you are getting, EIGA will give you the set of all eigenvalues. Okay, so these are the eigenvalues as the way I have defined this metric, just to demonstrate to you, because capital A was upper triangular matrix. So I can just format short first. Short, and then I can. Okay, so just so I can format short here, and then after I can see the A. So look at this matrix. This is an upper triangular matrix, and its eigenvalues we can read out 1, 2, and 1.2. So if you just make it something else, let's see what happens. So this is a set of, yeah, go ahead, please.
Hello.
Yes.
Sir, there are 2 or 3 questions.
Yes.
Sir, first question is, can we have the file regarding program for basic plotting features in MATLAB?
Can we, pardon, madam, please repeat this question.
Can we have the file regarding program for basic plotting features in MATLAB?
File, I don't understand what kind of file. So you have
regarding program
So,
for basic plotting features, sir.
For basic plotting features, you can just search documentation. Yeah, so many things are there. So you should not worry about this. If you want to search something for yourself, okay, right? So if you want to program something and you are not able to understand from where you should start, you just take the help from the documentation. Just look at this space. Okay, in the header of the MATLAB, there is a section, your documentation, maybe like eigenvalues. Okay, so put eigenvalues here, and let's see. So one window will appear, help window will appear. So let me dock it. So I think you are able to see this window now. So let's look at this. There is a topic on eigenvalues and eigenvectors, right? So you can just click this, and you can have all MATLAB commands of for your convenience. Similarly, for plotting commands, so plotting also you can search out. For plotting, you just feed the keyword. So here you need to feed the keyword. So I think here, so plot, just put the plot there, and you will see all the plotting commands there. So you can, you can self-learn MATLAB. So from this documentation. So look at this 2-dimensional plots we are discussing. So you can just 2D line plot. You can just click here. You can click this, and you have got so many things here, right? So you have so many options. So syntax would mean that what kind of commands you can use. These are the commands. So this is the first command is just use plot x and y. Then it will explain about, second will be line spacing and so on, so many things. And then after this syntax, you can just see the description. They will clarify the description also. What is the meaning of plot x comma y? So creates a 2-dimensional line plot. Just hold on. So you can just see if x and y are both vectors. So 2-dimensional plot between x and y. And if x and y are both vectors, then they must have equal length. This is a condition that of course you can plot only f of x with x when x and y f of x they correspondingly have the same values, right? No? Similar number of points, right? Not same values. So so this is the condition. Then if they are both matrices, then they must have equal size. They should have equal size. The plot function plots columns of y versus columns of x. This is by default. Columns of y will be plotted against columns of x, right? So similarly, the other things. So you can just read out so many things, and then after other options also, how to enhance the graphics, colors, and all that, right? So you can just go through this documentation and the various type of symbols if you want to use in the graphics. So there are plenty of commands are available, so you can just go through all this, and then specifications also. What kind of things, circles you can utilize, small plus sign, star, dot, and so many things are there, right? Square, diamond, and all that. And alternatively, once you have got the plot, you can edit it here also. Double click the figure, right? So from here, go to figure here, And figure, you have editing option here, right? So edit from here, right? On the top, you can edit it, and a window will appear here. This window you can utilize, change x-axis, y-axis, font, sticks, box or not box, and so on. So many things you can change, or you can click the curve itself. Click the curve, it will give you several options. Whether you want this curve to dots, you want this to be the dash dot, and then whether you want markers or not. If you want markers, you can just specify markers also, right? Triangles are being appearing here, right? So many things you have with graphics. So graphics in MATLAB is very strong thing, and I strongly recommend to all of you to use MATLAB for plotting things. Okay, and it's easy and versatile also, and so many other interactive things are there, because it is very much compatible with MATLAB. This one GetX also, right? Next, please.
Sir, can we find number of subgroups of a given group in MATLAB?
Number of subgroups. See, this question will not make sense unless you try to understand the question mathematically first of all. Mathematically, what is the meaning of number of groups first of all? So first, the thing is, MATLAB will not do any miracle for us. Okay, so if you can do this thing, this thing by hand, right? For some examples, maybe a group. So maybe subgroups of all subgroups of a group of order 10, say, right? So then what you need to do is you have to understand that mathematically, that how you will calculate it mathematically. MATLAB will not do anything different. The way you will ask MATLAB to do, it will do that. So program accordingly. Okay, so you just first write those steps for a finite group. What are the things which you need to do for checking out the number of subgroups of a finite group. I think the question is not easy to answer mathematically even. So it will to program it will be hard, and for that in that sense, I think we have a ready-made package called GAP. Okay, so so one should have look at that package that can instantly give you the answer to this question, as well as the others. That can for example, you have Jordan-Hildreth's theorem, so it can just give you immediately the sequence of subgroups there, right? And to check out the subgroups of a subgroup, a given group, it's not easy if for any n, right? So step by step one need to check. So for this we have different packages. So I do not recommend MATLAB for such purposes. Next, please.
Hello.
Yes,
Sir, how to export graphs to LaTeX and Excel file and words from lab?
So why do you need that? Because you already have a text file. You need graphics or doc files. You have you have already if you want to copy figure files, then it's quite easy. So you have this command. So I forgot to mention. Thanks for reminding me this thing. So how to print the graphics? Okay, so you have plotted a graph. So how will you print it? So let me just do this now. You have, and again here we have many choices. So you have, once you have a graph, you have plotted a graph. First of all, let me just see this graph, figure number 3, and I want it's a EPS file. Most of the times you use EPS file. Alternatively, what you can do is, if you want to directly copy it and paste it in this one doc file, so you can just right click here and copy it, right? So you can just, you have option copy, right? Copy and just paste as it, copy and paste. Otherwise, but I will not recommend this thing because of some issues regarding the fonts and some if you want a beautiful picture, I mean with good pixels and everything, then I will recommend this command to you. So this will be helpful. EPS file, construct the EPS file. So the command is print DEPSC DEPSC. So EPS file is, so it is about EPS file, right? And this C is for color. Okay. So this is the MATLAB printer now. So this is printed. So DPS EPSC, and after that you can mention resolution also. So if you need resolutions maybe 1200 or 612, it will be much more. So I just put 600 here, right? And then I can just put the for the name of the file, right? So name of the file is, so the name by with which the file should be saved. Maybe file one. Right? Let's see if it works. Well, right now, let me just move resolution. Just simple command this one. Okay, print DEPSC. So let's see if it works. If it doesn't work, I will just check it. So it works. So let me check out where the file is, and let me share the file with you. So this is the file one, which I need to share. So this is the file one, and let me share it with you. It is somewhere. Just hold on. So I cannot dock it, so because this is an EPS file. So here it is. I hope this is visible to you. So I can just magnify it a little bit. This is the file. So Dr. Pooja, is it visible?
Yes, sir. Yes, sir.
Yeah. So this
But
is
sir,
so nice.
actually, it's very. I think you need to zoom in, right? Sir? Actually, it's very large.
Yeah, a large. Okay. So now is it okay?
No, sir. No, sir. No, sir.
It's too large.
Yes, sir. Yes, sir.
Oh my God. Okay. So for what
Now,
okay. So but I don't know how to make it smaller. But one can see. I mean, just
yeah, now it's okay, sir. Now it's okay, sir.
oh, okay, fine. So this is how we can just make it larger or smaller, right? So finally, you can include it in your LaTeX typesetting, because EPS files by journals also these days, EPS or PDF files are demanded. So EPS output is the best one, right? So I think I recommend this thing. Okay, so I hope you have noted down this command, and we have several other things also that alternatively you can just do it by looking at the figure window itself. So if you go to figures, and then you can just go to the tools, and just you can check out the various things. Okay, so what you can do, right? So and the file, you can just see print preview here. You have print preview and export setup. You have so many things, preferences. So you can just go ahead with print preview also. So with print preview, let's see what happens. With print preview, I cannot share it. So okay, so let me share it with you. So I can share this also. So just hold on. So I want to share this window which open up. Yeah, this is this one. Yes. Is it visible? I don't know, because I'm not able to see any changes.
Yes, sir. Yes, sir. It is visible.
Yeah.
It is
So this type of window will appear, right? And then graph is in front of you now, and you can just style you can mention. Okay, you can just here you can just manage the what portrait you want, landscape, right? If you what kind of paper you need, right, to print on, and then use manual size and position, left, top, width, height, everything is mentioned here. Okay, so you can just play with this. Best fit you can find out. Best fit MATLAB will automatically calculate. Then centralize, if you want to center it, you can center it. You can fill the page also if you want to fill the page with the graph. So anything you want, you can do this, right? And then color specifications are also there. I don't know where. Color. Yeah, these are color specifications. If you want colored graphics, then it will print out color graphic, grayscale, everything is there. And lines and text, you can just go. You can just explore this also. And then advanced options are also there. And then you can just set it. First, you can just set this thing, print preview, while by going into files, and there you can find out this option, print preview, and you can refresh it. Then you can close it, or before closing, when you can just use the print command there. So you can just use the print command once more. So you can just do this, right? So I hope that this will help. Next question, please.
sir, can we export the analysis result in Excel, LaTeX, or Word?
Yes, because Excel behaves well with text files, so you can save the data in either dat file or text files, right?
Okay, sir. So next
So
question is.
then you can upload the data, yeah, in the this one Excel file. Yeah. That is possible. Directly you can write into Excel file also.
The next question is how to annotate the graph in MATLAB.
So there are so many things to annotate. What kind of annotation you need? But please, can someone can see, or he will retype. So precisely, I mean, ask precisely how many graphics you need.
I ask again. Sir, till then, can I ask next question?
Yes, Dr. Pooja, yes, go ahead.
So next question is, how to find stereography projection in MATLAB, and can we get the codes of built-in functions?
Course of
Codes of built-in function,
uh,
coding, sir. Can we find the
codes of
built-in functions?
building functions. No,
Yes, sir.
this question you should ask yourself, because this is, see, stereographic projection. You need to understand first yourself, right? You need a sphere, right? You need a plane. How to plot them? So MATLAB will MATLAB will follow your instructions. You are the instructor. So you are the instructor regarding preparing your programs. If you want to do stereographic projections, you just need to draw a plane. So you can just plot a plane directly, right? So plane is just a function. You define your plane to be a function of several variables, and then draw it, right? Once you draw, I mean, you can just draw something like a rectangle, right? And after that, but the thing is, you need to play with three-dimensional graphics. So plot three, instead of using the command plot two-dimensional graphics, you need to use the command plot three. Plot three will work, and then you have equation of sphere with you. You can define sphere as a function of and you have, in fact, you have stereographic projection. You have all points with you. You have the explicit expressions with you. Just play with that, okay? And I think convince yourself. So that will require your effort, okay? But that is possible. Yeah, of course, that is possible. Next, please.
Okay. So next question is, can we solve systems of non-linear equations of order more than 3 in MATLAB?
Yeah, any order you can solve. The only problem is, see, everything cannot be done in one package. I mean, there are a few things which cannot be done in MATLAB. There are a few things which cannot be done in any package, right? For example, if I ask you somebody to draw the picture of Dirichlet function, right, or characteristic function of rationals on 0, 1. So you use any package, you cannot do this, right? So there are a few things in mathematics which are weird and which cannot be done using numerical analysis. Okay, so there are some limitations, but yes, up to some extent you can solve. I think I have solved up to now, I think 400 non-linear equations, set of 400 non-linear equations together, right? So in MATLAB. So now you can just understand. You can do, because MATLAB does not distinguish the array and single variable. So whether you are using 10 equations, or you are using one equation, MATLAB, the method of solving would be almost same, because for several variables you have to use the higher dimensional Newton-Raphson method, right? Now the problem will be dependent upon the equations themselves. So if the equations are well behaved, if the common solution is not isolated, reasonably isolated, then of course you can find out using the Newton-Raphson method, implement it there, and you can find it. And there are other solvers also, right? So that's possible. Next question, please.
Next question is, can we have an example to show bifurcation analysis for the system of three-dimensional system?
System of
For
what?
three-dimensional system, sorry.
Equations.
Yes, sir. No, sir. An example to show bifurcation analysis.
Which analysis?
Bifurcation, sir.
Bifurcation.
Yes,
Okay.
sir.
Bifurcation
Yes, sir.
analysis.
Yes, sir.
I cannot right now, because this if you want to see bifurcation, so you need a precise problem in hand, right? And right now, no easy problem is coming to my mind. Of course, there are many easy problems, but right now it's not coming to my mind. So see, the problem in hand should be there before showing you something. So I cannot show you anything right now. But bifurcation point, you can just simply design right now. Maybe you can just take the your tent map. You can just go ahead with, or maybe in Newton-Raphson method itself, when you have two routes which are sufficiently close to one another, you can just see the bifurcation there. So bifurcation analysis is in itself is a very big subject. Now it depends upon you, what kind of things you demand. So as it is, I think I don't have any answer to this question. Next question, please. Hello. I think the connection is lost.
Hello. Hello.
Okay. So, Yes, next
Sir,
question.
can you suggest some books on operation research management, supply chain, and logistic management in MATLAB?
No, I can't suggest any book on this because I can only let you know about those things which I myself have done in the past. I hope that I don't want to be overconfident on this. So since I haven't used such kind of books, so I cannot recommend. I'm
Okay, sir.
really
Thank
I
you, sir.
apologies for this. Yeah,
Thank you, sir. These are the only questions till now. If there is
yeah,
any more, I will ask.
yeah, yeah. Thank you, Dr. Pooja.
Yes.
So thank you very much, participants, for asking these questions. See, your questions are always most welcome. You need to ask questions. So I will have to decide whether I can answer your questions or not. Okay, so that depends upon me. But that doesn't mean that you should stop asking questions. You please, whatever comes to your mind, you go ahead. Okay, so that way it would be, I mean, a boost for myself also, that you are attentive enough and you are getting whatever is being delivered here. So you can just note on this command, print depsc. So and if you want black and white, then you just remove the c from here. Okay, so if you perhaps I think I have this plot, so I want some color plot first, and then I can show you something. So let's see. So I think I plotted this one earlier. So let me check out. Yeah, this one. So if you want to have this one, print this one, you just remove c from here. You will just see. So first with c, I will just let you know file is same. So let's see. So these figures, let me share it with you. Yeah, this is so it's not there. Just hold on. So, yeah, it's there now. I can share it with you. So I can share this file. This is here. Yes. So are you able to see this file? Dr. Pooja, is it visible?
Yes, sir. Yes, sir. It is.
Yeah, so
It is
red
visible.
colored line you can see. So this was regarding the colored graphics, if you want the graphics in color. And the next one would be, if you remove C from there, EPSC, remove C from there, it will become black and white. For black and white figures, you can just do it this way. So where is the file now? Let's check. Yes, so I can, yeah, so look at this. This has become now black and white, right? So the file has been, so the curve has become black and white. So this is to demonstrate whether you want black and white your pictures, I mean lines, or you want something else, right? So color graphics. So both of them you can print as per your convenience using the same command. So I think I will not proceed further. I will take your doubts. If you have any other doubt, if you have any suggestion, you can go ahead with.
No, sir. All the doubts are clear.
Thank you very much for that, Dr. Pooja. And participants also, I am very much thankful to the participants for their patience, and with the hope that you will get something interesting out of these lectures on MATLAB. So the next lecture would be on solving ordinary differential equations, initial value problems using MATLAB. And few more, if time permits, I will try to touch upon some other topics as well. Thank you very much.
Thank Thank
Okay.
you.
Thank you very much, Jitender sir. So tomorrow, the first session you will you will handle the first session. That means from 10 to 11:30, and
Okay.
that will be your last session. So so you will deal with that ODs, I think so.
Yeah, I will do with ODs. Yes.
Yeah, ठीक है. Okay, thank you so much, Jitender sir. We are getting a very positive feedback for you, sir. So
Thank you very much. Thank you
thank
very
you
much,
so much
Dr.
for
Suraj.
spending your time. So we will meet you tomorrow at 9:55.
Okay, thank you.
Okay, thank you very much, sir. Thank you, Pooja ma'am, for sharing this session.
Yes, sir. Yes.
Thank you all. So participants, we will meet at 2:55. It's a break for lunch now. Thank you all.